was once I was moving to Red Hat, there was some, I forget this word, an assignment, yep. And the task was to build a command line application where you have some stream of flowers, you have some specification of bouquets, and then you have to build these bouquets from this list of flowers. So asyncio has a lot of synchronization primitives like queues. So it usually mimics a API from standard library. And how it is solved? So this is a primary function, which is async. So I have bouquet design queue, I have flowers queue, and some another queue, so won't make you confused. But what I'm doing, I'm creating a task where I'm assigning the flowers to the queue. Then I'm creating workers, which is, so we have a queue which will be producing flowers, and we have workers which is equal to, so it has, for example, 5 of them. It's not important now. And so once we create it, what we do, we specify worker ID and start processing. So, and until the stream of flowers will be empty. So we're creating, we take the flower from the queue. We are, so here receiving it, then we are using it. And if it matches, then okay, so we are using this flower and saying that so bouquet becomes one more flower, so fulfilled with one flower. And if it is not, then we put this flower back to the queue. So it's kind of loop. And then we are just allowing the loop to jump to next workers. So I'm using this sleep, and all my workers processing these flowers until all bouquet specifications fulfilled. So this is command line application. So we might try it. So you see that it called bouquets. It has this help, and it works. And we see here the different workers with different IDs processing this flower stream. Moreover, I'm using the asyncio application for reading and writing to files. It's called the AIO files. So this is very rough like overview that asyncio is pretty nicely suits the command line application. And I would like at the very end just to show you one cool feature, how you could use asyncio in any application, web application or command line. So if you have some synchronous task, like example pandas, so you still could parallelize it. And once you are querying your pandas, especially if the data frame is big one, you can do some job. So for that, so I will show you example basically how. Moment. Yeah, for example, the test item where function, so which you see here, that if you take asyncio loop, so there is a function run in executor which consumes the executors from concurrent features. It's objects. So it's thread pool executors or process pool executors, and you could provide your synchronous task like case item, and it will be run in a separate inside the executor. In this case, it's in a separate thread. So the main thread will be free and being able to do some additional job. And in this synchronous job, I'm basically looking for checking that data frame has something. It's pretty nice hack that allows you to easily making asynchronous jobs from synchronous one. So this is all my presentation, guys. Thanks for your attention.
Cool. So I think we have time. Thank you. I think we have time for questions. So if you have a question, just unmute and ask it. Or I don't know, if you're really shy, you can write that on Slack and I can read. I have one question. So maybe I will break the ice. So can you tell a bit examples of how are you using CLI with asyncio? Because I think you're right. Like most of the people is using asyncio on the server. I think I have one program that is a CLI that is using asyncio. But do you have an example of things that you can mention that are asyncio is a good solution?
Yeah, it's like, so you get the parallel between web application and command line applications that, I don't know, doing some initial startup scripts once you're running your CLI application, initializing your CLI application. So you could connect to database. You could do some initialization, like open files, whatever. So here you could do things in parallel. And you could use asyncio here. And if you're able to really, so if you have, I don't know, something which should be run in the background, like bots, for example, that you are checking something, check resources, or you have to with some frequency get some data, and you do not want that somebody would wait it, or you know that you could do some job here, so you also could here use asyncio. So the point is, maybe one is very convenient feature of asyncio, that actually you can do also multi-processing and multi-threading within your application using asyncio API. As I was showing you this thread pools or multi-process pools, then if you use, so you could use asyncio syntaxes with it, so you could await for something, and this task will be executed not some external server, but it will be executed on external thread. You could even create separate asyncio loops in different processes, and so it becomes even more crazy, but sometimes it could have sense.
Okay, thank you. So any other questions? Don't be shy. So as a reminder, we are going to have some time for lightning talks. There is a link. Jan, you want to repeat what's the link? It's a...
Hello, can you hear me?
Yes.
Hello. Okay. So yes, I'll show you the link again. Let me share my screen. I posted a link to our Slack channel as well. The link is simple. You can sign up via bit.ly/Py.Amsterdam-LT. This will take you to the form, and here you can just write your name and write your topic, and you will be given 5 minutes to present whatever you like to present.
Yeah. So good is that you have 5 minutes to talk. Good for us. If we don't like what you're talking about, it's only 5 minutes, so it's going to be fast. So I think, seems that there is no more questions. So Artem, thank you very much. I really like the topic. I work also in kind of a DevOps environment, and I'm using more and more asyncio for those things. So it's really nice to see more people doing that. Thank you. I don't have the applause sound in my computer now. So Andrea is our next speaker.
All right, thank you so much. Let me then start by...
So I want to mention that Andrea is also one of the persons that is organizing PyLadies Munich. So if you're, I don't know if you are planning to talk about PyLadies, but it would be nice. So cool, awesome.
Definitely. All right, so let me start sharing my screen. I hope you can now see a slide with my face on it.
Yes.
All right, great. Then, yeah, thank you so much, Jana, Nicolas, for having me here, and also Artem for that really cool demo. All right, so as Nicolas said, my name is Andrea Maldonado. I am based in Munich, and I'm a researcher at LMU Munich, and I am a Pi Ladies Munich organizer. So here, together with these beautiful people you see on the pictures, we organize the Pi Ladies Munich chapter of Pi Ladies, very much as Py.Amsterdam meetup. So what do? We also are in the meetup scene. Here you see a picture of our last meetup, offline or on-site. But also on the online scene, we're there and we are organizing so meetup. So if you feel like this is something that you would like to participate in, please feel free to join. Okay, so why Pi Ladies Munich? Our vision or our purpose is to encourage more women into taking more protagonism into the Python scene. So you can support us by coming to our meetups, also by hosting us when this is like on site again, or now even online. As Nicolas said before, we have the huge advantage of being able to have speakers all over the world. So if you feel like this is something that lies close to your heart, don't know to then come to our meetups or write us about if you feel like being a speaker. All right, so let's go to our presentation of today. Today is not love in times of Corona, but applied machine learning, leak detection in water pipelines. And let's start with a small motivation. Why did I look into this? As I mentioned before, now I'm a researcher at LMU University, but before that, I was doing my master's there. And together with a group of 6 cool people, we decided to have this project as a kind of hackathon during 1 week when we tackle this task of finding leaks in water pipelines. Water is one of our most important resources. We need it to sustain life. And as humans, we have developed very fancy ways to make water come from the source to the convenience of our homes. And considering this, during this travel of water to our homes, we don't want it to get lost on the way. And therefore, we want to avoid some leaks. We did this hackathon in cooperation with the LMU University in Munich and also the SVM, who are the responsible people in Munich for the water network. You can imagine you need to look a little bit like this picture on the left, where each number is a station for measurement, where you can imagine there is we have this fancy equipment of having one microphone attached to the pipelines, and there you would then be able to listen to the relaxing noise of water going through pipelines all day long if you want to. All right, so if that's maybe not your thing, but you still want to detect leaks in water pipelines, this worked in the following manner. So we have these microphones on pipelines spread across the city, and these might be also in different distances to each other. If there would be a leak, for example, here in node 1, then you would be able to listen to the microphone on that node and then recognize that there is a leak there if you're an expert. Other than that, if you have something between, for example, a leak between 1 and 4, then you probably would hear both in the microphone or in these audio recordings, and you would be able, via, for example, geometrical triangulation, to more or less locate where this leak is. All right. Well, yeah, those are the ways. We also, as a yeah, as something to be considered is also that there might be other noises that are also recorded by these microphones. For example, if this microphone happens to be very close to an autobahn, then you might also hear cars going through, and you might have overall some not wanted noise, like besides the water lake. All right, so to do this task, we first went back to the roots, which meant for us taking a look at noise itself. So you might know this picture on the right from some sci-fi movies where there's some voice talking or something, and what you have here is that noise is represented as waves, and the aggregation of these waves over time give you that plot over on the right side, the red one. The blue one, on the other hand, is then a so-called Mel spectrogram, which is the objects we worked with. And what you do here is that you have a constant time frame, and within this time frame, you then plot the frequencies into the frequencies into the x-axis. So this is how it looked on the input. So to sum up just the pre-processing, we had some raw data. We then cut this data, and the raw data were these audios that you would be able to listen in order to sleep at night. Then because we didn't want to do that, what we did is then we split this raw data into snippets. So that means a few seconds of this audio, and then we did this these transformations to then end up with a Mel spectrogram, which visually looks a little bit like that picture, but other than that, it's a matrix. And if you know anything about machine learning models, well, matrices is what we can work with. All right, so here I have an example on how anomaly detection fits into everything into this picture. And you might already notice, if you're a human, that one of the objects here is not like the others. So, but if you're a machine, this task might not be as easy. You could then do something as plotting the size and the number of tones of brown that one of these objects have, and then plot that into a visualization where, if you're a machine, then you can make some split and say, okay, for any new object, if it falls on the right side where the majority are cows, then it's a cow. And if it falls on the left side, it's some kind of imposter. All right. So for this, we added also some other flavor to this, and it was the autoencoders. What we used for this was, for example, or how you can imagine an autoencoder to work is if you are a photographer and you take very high resolution pictures, you know, they take lots of memory. So you might come into the idea of compressing this picture into some low dimensional object. In this case, we are talking about vectors. Then later in time, if you want to take a look at this very high resolution picture that you took, then you want to decompress that, and hopefully the output will look exactly as the input before. So there will be no loss. An autoencoder works very similarly. The thing is here that the input and the output might not look the same. So instead of compressing, we talk about encoding, and decompressing is decoding. And at the end, you have this low resolution picture where you know, okay, some information did get lost. But for us, this is exactly what we wanted to use, because because the trick of autoencoders is that if you learn a model with similar data, it learns to reconstruct that specific kind of data very well. So if you would learn it with, for example, flowers, then at the end, the autoencoder would be very good at reconstructing flowers, so the loss wouldn't be as high. If you give then this trained model a picture of, let's say, a cow, then probably then the autoencoder wouldn't be as good as reconstructing the cow, because it is different than a flower. So and it would kind of scream, okay, I'm very bad at reconstructing this, the loss would be huge. And then using this, you could say, okay, if the loss is huge, then there might be some kind of anomaly, something funny in there. And this is the trick behind the autoencoder for anomaly detection. We used three, yeah, here is again, instead of flower pictures, we have our matrices and our MEL spectrograms, since we are looking into audio. And then we have some encoding layers and some outcoding layers. Outcoding encoders come in many flavors, and we decided to try 3 of them. We have the simple autoencoder, the convolutional, and the variational. Let's go over them very quickly. So for the simple autoencoder, we tried having 3 encoding layers and 3 decoding layers. Here you can see some example pictures of how it looks like on the right and how on the left, and then how it looks on the right. We used dense layers only, and we experimented with vectors between the dimensions of 3 and 300. As I said before, we are training our autoencoder by giving it similar images. So in this case, we are giving the autoencoders of our choice, some MEL spectrograms that we know do not entail any water leak anomaly. So it learns with them and gets better at reconstructing them. All right, so we also tried the convolutional autoencoder. Here we tried different numbers of layers, and again you can see some input and output. And then last but not least, we also have the variational autoencoder, which then works on principle like this. Here you encode and you don't have only one vector, but you end up first with 2 vectors, one representing the mean and one representing the standard deviation. Then you transform these vectors to have this information into a single one, and then you have the decoding part as we had before as well. All right, so if you would have this in a 2-dimensional space, as here, the main difference between a simple and a variational autoencoder is that for the simple autoencoder, you would have a dot with information about that dot only. And for the variational encoding, you kind of encode not only information about the point itself, but also its neighborhood, which is, and still use the same amount of memory, which is quite cool. All right, so now let's go into training. What we did is we had then all these pictures that we run through the autoencoders, and then we are comparing the input and the output for all of these MEL spectrograms. We then get some laws, and you may know from machine learning, then we train with these laws, we train some weights, and now you know from machine learning that with some weights or new weights, there might be a new model. We did this a couple of times, and then we end up with a trained model. So now the data classification into anomalies or not begins. What we do here is we then now have a new file that we use as an input. Here you can see then these different MEL spectrograms, so these snippets of the one audio file. And then we also put it into the trained model. The trained model also tries to reconstruct this and ends up with some output like this. Then we compute some reconstruction error, which in our case was the mean Euclidean distance per frame, and at the end we get some sort of classification. All right, so we did this, and then we looked at some pictures. So here you can compare for the CNN autoencoder how it looked like with the original. You have on the left no leak, on the right some leak, and then we put both into our trained autoencoder, and then we take a look at the reconstruction. And if you are human and you are looking at this with your bare eyes, you might notice comparing the bottom 2 pictures over here that there is, well, basically not much difference. You're more able to say there was a leak before than after. So we look at this, we took a look at this, and then we were not discouraged. We decided to plot the reconstruction error to see what was going on. Here you have this plot, and what you can see is first, okay, so we have the reconstruction error on the y-axis, and we have our snippets on the x-axis. In green, you can then see the reconstruction error for those files without a leak, and in red you can see the reconstruction errors for those with a leak. All right, something different that you can also recognize here is that we have some serious peaks going on over there. We also then decided to zoom out to take a look how big are those peaks, and turns out they are pretty big. And if we then try to make the split here, you might not even see a big difference because the noise of the peaks is too loud. Nevertheless, it is possible for us, to make some sort of split. More on that later. First, we were interested on those peaks that you see over here, so we took a closer look. We then found the corresponding MEL spectrograms, and turns out that exactly these peaks that you see on the reconstruction error plot, you can see having some kind of different anomaly on the MEL spectrograms. The next step for us from here on was, okay, let's listen to this, let's see what is going on. Turns out that for the upper audio recording, there was some car going over over the sewage cap, where you could then hear the you could hear them driving on it, and then once it gets in, then it gets out of this cap, and then of the tap, and then this was the noise that we were hearing. Even funnier, for number 3, it happened to be some dog that was also probably hungry and decided to give a concert that the microphone also recorded. All right, so we don't want to recognize this, or we don't want for the autoencoder to say there's a water leak whenever your neighbor gets hungry, but still in our case the autoencoder or this training was able to do some sort of classification. As I told you before, here we can, much as in like the cows and the imposters, draw a line and say for new recordings, everything that goes on top then has a leak, and everything that goes on the bottom has no leak. As you see here, there are already some points that are over this threshold line, sorry for that, and still are some recordings that have no leak, right? So this might be this hungry dog, and well, this is an offering of improvement. Well then, we have now our classification, and just to summarize, we have then our input file, then we calculate our reconstruction errors with using the reconstruction errors for this for every frame. We compute then we do some classification where 0 would mean okay, probably no leak, 1 means probably some leak, and then we choose some threshold, in this case 0.4, and by computing the average of all the snippet scores that we got, so these 0s and 1s, we then can say, okay, this is over the threshold, so that let's say there is a leak there. How we did overall, here is a confusion matrix. You might already know this kind of matrix, but what we have here is that in a perfect case, the predicted label, so whenever our autoencoder said there is no leak, the true label was actually also a no leak. So this is what this one, so 100% of the cases are right in this regard, is what you see here. And then whenever there was a leak, our autoencoder would be able to predict that there's also a leak. That was this, that's what this little, like on the bottom right corner, that one means. And overall, if you already read the title of the slide, you might also recognize that these are the actual results for our CNN with dimension 2. Of course, we got these results and we got skeptical because no model is probably so good. But the thing is that then we concluded, well, probably our split was not big enough, and there were not so many cases where we actually have that leak after 1 week. All right, still, as we did many experiments, we were able to compare to other autoencoders, and here we see that our implementation of the confusion matrix is might not be just super faulty, and that's why we have this perfect classification before. But if you compare it here to the simple autoencoder, you can see that there might be still some cases where the autoencoder or our model said, well, there must be a water leak over there, where the true label says, well, not so much. And this was kind of half of the cases for the simple autoencoder. Yeah, I would very quickly go to over the the area, the rock area under the curve that you can see here. Again, we have kind of this perfect score that you can recognize for the CNN, that you can recognize by this vertical going into straight into one, and then this horizontal at one, which is kind of the perfect score you can get here. For comparison, also a simple autoencoder with dimension 10. And well, that's that. After a week, we decided to count our successes. For us, it was a big success to see, okay, to get the pipeline set up on multiple systems. And even better, we documented this for future generations, since this proved more challenging than we thought at the beginning. Also, through our different investigation and in the audios and in the different plots, we also gained some exciting knowledge about the autoencoders and about how reconstruction errors translates into several settings. And we also learned about some promising deep learning methods also for this task. As a future work would be, as I said before, improve the single misclassifications, as you don't want the water, you don't want SVM to run into your home every time your dog might be hungry. And I think we could also have some advantages of running more experiments in order to tune the autoencoder better. Yes, so that's all from my side. Thank you so much, and I'm open for any kind of questions.
Oh,
Thank you.
super good.
Yeah, I actually have a question. What kind of a system requirements does it need to have to run the recognition? Not to train the models, but to use it.
Yes, actually, thank you. I kind of forgot. I also had this slide over here for that case. So what we of course were working with Python because we love Python. And on top of that, we were working with TensorFlow and Keras on about then the let's say the hardware per se. We were able to run our experiments on some university clusters, so we had a little bit more power over there. To train. For the classification, we actually did everyone like on their own laptops. Some of us had like, let's say, smaller, less powerful laptops than others. We had all kinds of operational systems. So we had some MacBooks, some Linux, and some Windows, and we documented how to install this for everything. So yeah, that would be, I don't know. I hope this answers your question.
Yes.
Great.
Someone is asking in his Slack if you are using GPU for the training, or is
all right. So I remember that we actually had one GPU at our disposal for the training. We didn't use it for all the training, so that means that also some training was going on overnight, and while we were actually hoping to really get it to get to set it up. The thing is that even though we were theoretically having this GPU at our disposal, actually putting our code there and connecting into the computers that we had from university or our home computers was a little bit more challenging. So we spent I think we spent like 2 out of these 7 days or 5 days of the week tuning this setup in order to work. But I know that partly we did train on the GPUs at the end.
okay?
Thank you.
Nice. Any other questions? You can just open your microphone and ask.
I have one question, Andrea. I just was thinking how we would approach the problem, and it's interesting, like what pushes. So, which technical limitations pushes to this kind of solution? So, like, who was a kind of stakeholder for this project, and why does they decide to put a bit on the machine learning here? Just maybe some kind of context.
Thank you for your question. All right, so it started with, so our stakeholder or the people bringing our use case and that we're hoping for a solution here and the people from SVM. The state before um, our approach was that someone would run, like would go every, I don't know, like every n months or every year through some pipelines, and they would yeah, like through the city, and then they would listen into a pipeline, and then an expert would be able to recognize if there was a leak or not. Yeah, in that case. So this would be the firmware approach. Of course, is not as resourceful, and here, if you are able to automatically detect the water leaks, you are yeah, you might be also able to handle it faster. Also, for this, or what was exciting for us in this machine learning approach or on this challenge, was that we were working with recordings, like with audio recordings. I think another solution that you often use to kind of yeah, recognize leaks in water pipelines is that that you pressure the that you measure the water pressure in the pipelines in order to see, okay, maybe there's some water getting lost somewhere and that we didn't expect. The decision of SVM to use microphones here instead of that and audio recordings is that it, from the hardware side, it is cheaper to then just attach some microphone on the pipeline with some tape than yeah, buying some more expensive barometer.
Yeah, thanks. I just got an idea that it could be possible to split this pipeline into sections and for, I don't know, very short time period to close these valves and measure if there is a pressure gauge, it's like start deducting interferes and to fire up that it's leakage. Yeah,
Yes,
just like idea, I'm not sure. It's from
yes,
my,
definitely. As in like water pressure, you mean, right?
it seems like pretty reliable.
Yeah, I think this is very often the approach that is being taken. But then, if you're like closing and opening the different keys, you might also deprive some people of water then for a few hours. And yeah, then I don't know, maybe they want to avoid this kind of complaints of people not getting their tea or something. So yeah.
Do you think
Mhm.
that you can, because at the end it's a quite simple solution, right? It's just recording the audio and processing it. Is Do you think that there is other use case for this, like using a similar, like maybe with a different training, I don't know, but with a different input, but that you can use the same for other use cases?
So sorry, to be sure, is your question if I see any other kind of solution with different variations where we could also, yeah, leverage on a better solution, yeah, or like other approaches how to solve this, or
No, no,
like how do
I
you
mean
see the choice in other?
using like audio as an input and neural net and the pipeline that you were using to process for a different problem. For this
Yeah.
one was the water leak. I would expect, I don't know, maybe petrol or maybe other problem that,
Mm-hmm.
because I think it's a really cheap and simple solution, right? It's
Yeah,
but
agreed. Now I got you. Thank you so much. All right, so I think definitely. I think this solution might be really good and even better for some use cases where you wouldn't have such a high variation or such a high variation or such peaks as we saw before in the data. So maybe here in these water recordings, where you have like, yeah, other autobahn or other kind of noises that are actually also mixing sometimes into this approach. So wherever you have like homogeneous data, like for any kind of, let's say not water leak, but like some very standard anomaly detection, this is a very simple solution that you can use for any, yeah, for any kind of anomaly detection in that regard. Then if you add some more variation on the data, so let's say you're looking for a certain anomaly over here, then it gets a little bit trickier. Although we also thought about training differently. So if you would have lots of data of this anomaly, as here, if we would, yeah, we also considered or on training maybe not on the non-anomaly data, so like not on the pipelines that do not have a leak, but training on the pipelines that do have a leak. So the reconstruction error would be low for those and then high for everything else. This was another approach that we were also considering. But I think, yeah, I think I agree. I think like for any kind of other anomaly detection, probably also like, yeah, visual anomaly detection, or even for validation of some models, like if you would then compare, yeah, if you would then compare, yeah, the predicted output with some output, and then you want to check the difference between them and see if there are also some anomalies that would be, yeah, that could work, or even maybe like for a pre-processing of data before you want, like of labeled data, for example, if you want later to use that labeled data in some other context.
Mm-hmm. Thank you. Thank you.
Thank you too.
So we have one more question. Yeah.
Yeah, if I may, can you hear me?
Yes.
Yeah.
All right. Yeah, thank you for a very interesting presentation. I just want to clear one thing, if I understood it correctly. You had around 7 like microphone locations, right? Where different microphones were placed, like roundabout. Or where you had data from only a single source of those?
Oh, we did have more microphones than just 7. This was just like kind of an abstraction to show this to you. But at the end, I think we had over like 100 stations where these microphones were attached, where we can and the data. So we did have like several recordings on the yeah, that we were investigating.
Okay, so with that in mind, I wanted to ask, have you tried not using a single location's microphone in training and seeing what the validation score looks like? Because does it generalize to microphones that it was not trained on? Maybe they are very different.
For this approach, we actually did not take into account the location data. So we did have like, we didn't have the location data itself. We only had the recordings, and we had some, yeah, we only had the recordings, and we had some labels of, yeah, for the training data, we had some labels of, okay, these recordings, yeah, do contain a leak or do not contain a leak, and that's all. But we didn't bring location into this.
Okay. Do you think this could be a problem, that if you apply, like you install a new microphone at a new location and then the model suddenly no longer works because the sound is a little bit different than it's trained on?
Well, I think that since we are comparing then the all right, so I think for this case, you will need to first maybe gather some data on that new mic that has no leak, right? So that the autoencoder also learns how to reconstruct and how it would look like when you have no leak, and then yeah, you would need to retrain the model for this. As far as I understand, yeah, as far as I think, yeah, definitely. Although I think that the point, so this is like this would be if you want to add another mic. Although, like, if you already kind of plan, okay, you know what are the strategic points on the city that you want the mics to be on, and you would take this into production. I don't think that adding a new mic would be something that would come ever so often, but rather something that would be stable, and then you would get the more and more recordings. Of course, you can get some, yeah, you could still like get some. I don't know, like if someone spontaneously then gets something that then, yeah, as I don't know, like a dog, or if you would have like an autobahn constructed very near to this new mic or to any other microphones that you already have there, then still there would be some kind of retraining loop necessary. Although like all the scores would go probably a little higher, so you would also probably be still able to do the split to say, okay, even the reconstruction error for the no leaks got a little higher, right? Because this is also unexpected, like this new noise is also unexpected on those.
All right, thank you.
Thank you.
Cool. So thank you very much, Andrea. Muchas gracias. That was a super nice talk. So now we are done with the 2 talks for today. I think we're going to move to the lightning talks. I see two in the sheet. There is time. If someone wants to present, there is still time. I'm just having a beer because I missed the real life meetup, just sharing some drinks. So cheers.
Here.
I want to mention that we are using the EuroPython Society Zoom license. EuroPython is sharing that with other Python communities. So if you are related to the community and you want to organize a meetup or something similar, you can ask EuroPython to support you with the Zoom licenses.
Yeah. If you don't know how to contact the EuroPython, just send email to info@py.amsterdam and we will put you through.
Yeah, I'm for sure. I think you can. It should be easy to find. And so, Jan, you are the first one for learning talks. For if anyone doesn't know how it works, I'm going to put in my phone. I'm going to put a timer. So 5 minutes.
Oh, this is so annoying. How can I move? Oh, fine.
So 5 minutes there.
So tell me when I start.
Now.
Okay, so I will start with my with PyJokes. If anyone doesn't know what the PyJoke is, PyJokes is a joke as a service. It provides an CLI and API, and with just one command, you can get some nice jokes, or not so nice. It depends. For example, what's the object-oriented way to become wealthy? Inheritance. So let's run it again. There are two types of people: those who can extrapolate from incomplete data sets, etc. And why I'm talking about PyJokes and their API. A few years ago, I decided to build my first Slack bot. If you don't know what Slack is our communication platform. I'm pretty sure I don't need to introduce it further. But when I started to learn, look for a Slack API, Python Slack API, they had some sort of working thing. It was very difficult to use. It did not have implemented almost anything. All that the library did was just saying call this method, and you had to supply a lot of things, all the parameters, and even the method name. There wasn't anything nice. Later on, there was a new library called Slack API or something like that. Everything is under this organization on GitHub, and that library got a little bit better, but I was still jealous about the JavaScript library. And this year, again, I wanted to build another Slack bot, and it seems to be a custom of a Slack team that every time I need to build an application for Slack, they release a new SDK. So every time I'm on the bleeding edge of Slack SDKs, and I'm learning new technologies. The good thing about this new SDK, it's called a Bolt -Python. -Python because it's a port, somewhat port of their JavaScript API. And this is a very mature SDK. You can just install it with pip. Then you create a Slack Bolt application. This application then can listen to events or commands, and you process them with convenient methods. You can parse the commands and the messages with regexes and get very nice event handling. And if you've ever developed the Slack application, you know that the Slack by default requires a response within first 3 seconds. And then you need to use a respond URL. And this library also provides you with the convenience to respond to the Slack, and then you can respond what with the payload you really want to respond. It has can be integrated with multiple web frameworks using the adapters. This is, for example, how it looks if you are using it itself. You just call add command, your command name, and then you receive your response and a body from Slack. And with the respond method, you reply back to the Slack. It has multiple adapters: IO HTTP, AWS Lambda, bottle, Flask, a lot of examples. And why did I talk about PyJokes? Since they have API, you can integrate Slackbot using PyJokes API and send yourself or your colleagues some nice jokes. And that's it.
Nice. Happy to see that is. So that's your 5 minutes. Cool. So Artem, you're next.
Yeah.
Thank you, Jan.
Thanks, Jan. That was
So
awesome.
the title for Lightning Talk for Artem is Git Flow Wars. Do we need to merge often?
Yeah.
Yes.
Not everybody shares this opinion. Unfortunately. Yeah. I would like just to initiate some problems so we could have some later discussions here. So I never heard too much about Git flows, and I was thinking that it's something not that important and it doesn't worth to pay too much attention, just like doing merge requests, merge, whatever. But after starting work in a new team, I figure out that it is pretty important, because I have now 7 merge requests which is not merged. And the reason is very long code review. Another one, quality engineers waiting for release, and they are not starting to verify your merge request. And kind of these reasons. So this is important, and I was start digging into because I was irritated by the problem that I have 7 merge requests, so I'm not interested to start rebasing to the some most recent commits, because you're like, what is the sense of it? So still 7 of them. So I find out that there is like GitLab flow, there is classical Git flow, and there is one flow. It's all it is conceptually a bit different ways of managing like teams to progress and evolve their code base. So it seems that one flow might work, and for teams up to 10 people, there is a lot of specificity here. So I'm wondering, what is your experience? How do you actually managing that, keeping some stable branch, which is if for production systems should be verified by some external team, and still able to take care that people are flexibly could merge without too much burden? Yeah, this is a question. And finish.
So in the past, connecting with Jan talk, in the past I wrote a bot that was spamming my team channel in a former company with my pending to review pull request. And the bot was offering a beer time to time, like saying, "Oh, I will pay a beer for the person that would review this pull request."
But this is one of the way to solve it. Everybody would like to get rid of this bot. So
It's not a matter.
Yeah.
It's not a matter of how much time do you have, but how much beer do you have, right? In this case.
Yeah.
And yeah,
I have no idea. I
really. Yeah, sorry, be my guest.
No, I was saying I have no idea. I tried to use this Git flow, I think, in the past, but was not easy to have a full team on board, right? Because you say, okay, let's use this tool, and then you are 6 or 7 or 5 or 8, and it's not the same for everyone. So I ended always going to just vanilla Git and having pull requests. But the only thing that worked for me is that we have like a budget, like I don't know how to translate that. So at the end, we were saying, okay, when there is more than n pull requests pending to review, everyone stop doing whatever they are doing and start reviewing, and we moved that to 0. But I think that was in a team that we were 8. I would say in a bigger team, or if you are depending on reviews from cross teams, that won't work. Then I have no idea. Yeah, I would like to have a single one, right? Like a single flow that works. But
yeah, we had I think on this regard we tried 2 different strategies when I was working in industry. The one was very similar to what Nicolas just mentioned, by having so by when you would finish your own ticket, and then you would be able to pick another one. The first thing you have to look is there anything to be reviewed? So if there was anything to be reviewed, you was supposed to do that first before you take on new tasks. I used to work in a smaller team, so we were, I think, like 5 or 6 tops at the time. But that worked pretty nicely. And then, on a plot twist, what we also tried out was a very different branching strategy. I don't know if you have heard of trunk-based development. This is also, so we tried this for a bit, and this is also recommended if you have more. So there's a couple of things. So for example, if you're basically trunk-based development, for those that, to refresh the memory, is basically having no branching at all, and then branching into master and the whole time. This has a couple of advantages. It also comes with some responsibilities, since everything that you are branching, then you still have some reviews. You are but it's more critical. Whatever you're really committing and pushing into a branch is more critical. So this is also recommended for more senior developers, and also for projects that are well established, let's say, or that are not that new, where you're adding more stuff rather than developing something like from the start, right? Where you already have, let's say, like a strong thick trunk. So this is
so sorry, because I never heard of this trunk. It's basically like pushing to master.
yes.
I will die. I consider myself a senior engineer. I've been working for 15 plus years, and I would really scare if I had to push to master, because I really trust my life in all the continuous integration and test. And I will just I will be not sleeping at all.
Yeah, I understand. I think also the so there's a couple of things behind this, because it's very counterintuitive, right? As you said, I wouldn't sleep if I would know, okay, my code is already on master and let's sleep. But I think what this also kind of to encourage is that you are pushing more often, and very small changes. So the impact is not as big every time. And also, I think there's I don't have this so fresh anymore in my head, but I remember reading a few tips, and also knowing that the idea behind trunk-based development is that actually it might be very although you would think, okay, this is going to be a disaster, knowing these people are even more careful doing these changes, and they are actually committing committing more often, pushing more often, also having some kind of alignment on documentation, on assumptions, on how you make sure that that this works. Also, like having so you need maybe more synchronization. You probably have some synchronization overhead on the communication with your team, but then it's a matter of like where you want to put your time, I guess. If I find, I remember reading a really good article about this. If I find it, I
was Googling trunkbaseddevelopment.com. There's a
all right.
webpage.
That sounds very like one-sided though, but yeah. But yeah, why not? Yeah, but it also,
I think it's a super interesting topic. It's and we are already more than 5 minutes, but just I just turned off the clock because it was more like an open discussion. Something that Andrea mentioned, I think is super important, is small changes. So if you have a pull request that is huge, everyone will be like, "Oh, come on, I don't want to review this. It would take me 2 hours." So if you can do small changes that are easy to review, then it's like you are, and also if you are helping the person that is doing the review, that's also, I think. But the Artem, your original topic was, okay, is a Git flow or is some flow to follow? I have no idea. It's because at the end, all these tools are just a convention, right? So they are building a tool to support a convention. At the end, it's that, right?
Yeah, and I just had in my previous team one guy, and he was never like mentoring me directly, but just the way he was doing it, I was struck, and in future I started realizing how wise he was in doing some stuff, and the way he was doing merge requests. So he did around 5 merge requests per day, and it was a kind of story. So it wasn't like that he was introducing the feature, but he was always creating a ticket for a feature, and he started referencing merge request to this. And it was always very small. He was like, there could be a merge request, we just try something, and it could end up that it doesn't work. So with the result, he said it doesn't work, so he was reverting it. But the way to review his work was so convenient, since it was very small, and you were always in the context, actually, why he is doing it, what he was already tried. It was awesome. Like, so now I'm tried, but it really depends on your team and how they get used to it. So if they have a project of like 2 or more years old, so they have some like concrete system of work that is really hard to move it. So, for example, now I'm quite often being queried that why do you create 3 merge requests if you can do it one big? So I will review it once and I forget. Another advice is just like, I don't know, it works for me very so effectively that it is normal that you can say I approve it, but like, and created follow-up ticket which is requiring some fixes in future, which is not critical. The feature is working, the code could be understandable, but just like future. But instead of blocking the merge request from being merged and putting this request required, you could just approve it and say that create the follow-up ticket, and this is works absolutely. So it creates a kind of this dynamism, and this is very, so it's improving the productivity once you are like able to merge in more rather than waiting for weeks for getting one merge request. So yeah, just sharing this slide because it was very
Okay, still, I think it's a super interesting topic. And the dynamics of how you work in a team is also really, really hard. I've been working this. So this year we started the official Python documentation translation to Spanish, and that team is growing a lot. It's more like it's like a 130 persons in a chat, and there is a lot of people doing translation. And in that project, the hardest part is review. There is 1 million pull requests to review, because and because some people is scared of doing review. I don't know why. And and that's also a different problem, right? Like when you are in a team, you can spam your teammates. But in an open source project, and there is a 40 pull requests open, and maybe there is a small group of people doing that's a lot harder. And then you start having these conflicts, right? When you want to merge. And for me, it's like I'm start doing like reviews there, and I end doing a lot of solving some conflicts and doing some merge more than review. I don't know. I would like someone to have like a perfect recipe. But for me, I would say a small pull request, and then try to push for what you are doing. You have to be really good explaining what you're doing. Also, I think if I open a pull request and it has some summary and it has I don't know, like example of if it's a website, a screenshot, if it's a CLI, just a copy paste from the how you change it, how is the output, how are the logs. It has tests. I can go and see the test and see what you did. I think that's also a good way to help others too. And then if that doesn't work, just spam them. Just start sending an email every minute.
Yeah, I think yeah, that's very good. And I also think it's a super interesting topic, and it also relates a lot into several other tests or aspects into your team, right? So it's like, okay, how are you doing testing? How are you doing um yeah, how are you, like, where do you have the centralized knowledge about a certain ticket, or where does the knowledge persist in the documentation? Or is it more like, okay, this is something I need for the ticket or for the code itself? Yeah, and I think, I mean, even if like maybe I remember that some manager I had was a very trunk-based development believer, and I know that also like transitioning from having several features in GitFlow and then into this trunk-based thing, it's quite scary and it's a lot. But I think maybe something in between would be a good match, right? So as you were saying for Artem, like having also this small pull requests. And small prerequisites that you're reviewing constantly instead of having like the one big thing. Although one might think, okay, yeah, one big thing might be the same time with just less context changing than the three smaller, right? But that's something that probably also depends on how you test, how you have.
I think it also depends a lot on the product. I think Facebook, for example, is something in the middle. So in Facebook, I have a friend working there. So basically, there is like I don't know what's the name, like a train. So you merge, and every time to time there is like a cron that it will deploy to production. So if you merge something and there is a bug, then you need to merge a fix and wait for the next deployment to catch it to go to production. And maybe Facebook can do that because it's okay to have like a button that is in a different color. I know in the company I work, if I merge something that will break our systems, I will prefer wait for a month for the merge to for the review, because the impact will be huge. So it's it depends a lot on what's the thing that you're doing. Or if you are working in, I don't know, SpaceX, and there is a code that is going to send an astronaut to the moon.
Yeah, right. It even also depends on how you're deploying, right? Because if you have a multi-stage deployment, where you have many stages before it goes into production, and you would be able to see the bug before that, then you might feel more comfortable into pushing, right, and into merging faster.
Yeah.
Okay.
Or we have something on the agenda, right? So like.
Lightning talks. That was the last one. So I think we are done for today. I don't know if anyone wants to mention anything or have a question. Otherwise, I would say thank you very much, Andrea and Artem. Thank you everyone for joining us. I hope we are going to see our faces again maybe in a month. Let's see. Remember, if you are interested in presenting on the meetup, go to Py.Amsterdam and you can submit a talk there. I think I'm not forgetting anything else. please, if you want, if you feel that you want to do that, send us some feedback. If there is anything that you would like to see here, let us know. We are really open to test new things. I think we did some kind of workshop only once, but that's. I think we are still in discovery mode, trying to understand how we want to do. And the winter in Europe looks like it's going to be a lot of staying at home. So maybe we can find some some ideas to keep ourselves busy and to share also, and to be able to talk with other people, because otherwise it's going to be really hard. So we are. If anyone has some idea and they want to try it, please reach us, and we will do it for sure. So thank you. Good evening.
Thank you also, Jen and Nicolas, for organizing this. I really like this format. I enjoyed it, and everyone who participated as well. It's really cool to see that the community is still online and kicking. So that's great. Thank you.
Okay. Thank you, everyone. Bye. Good evening.
Bye.
Yeah, Jan, do you have a couple of minutes? I was thinking to chat with you a little bit.
Oh, sure.
Oh, great.
I just
Thank
need
you.
to attend to my cat, so